Hello guys, so today we'll be doing absolute value functions, and just a lot of you have experience doing absolute values. We're going to do graphing as well today, but just to remind you what absolute value is, it is the distance away from zero. And the best way I can explain it is using a number line. So for example, if we have the absolute value of -6, that is equivalent to 6, right? And on the other hand, the absolute value of 6 is just 6, which makes sense. Put -6 on this number line, and we put 6 and -6 on this number line, we can note that it is the same distance, both points are the same distance from 0. So whatever you have within your absolute value brackets is always going to be positive. All right, so for the first example, we have the function of the absolute value of 3x minus 2. We want to do three things. First things first, we need to find the value of f of -1 and f of 2. So just like how you've done previous examples, you treat this basically the same way. So I'm going to have f of -1, replace -1 for x, and go ahead and simplify.
This turns out to be -3 minus 2, which is -5. Okay, again, absolute value of -5 is going to be 5.
Okay, so let's go ahead and do f of 2 now. So for f of 2, again, do the same thing. Plug in 2 for x.
Simplify, you're going to get 6 minus 2, which is 4. Absolute value of 4 is just 4. So f of 2 is 4. Or f of 2 is equal to 4.
Okay, let's go into b. All right, for b. We have the following questions. Asked us to find the values of x, for which f of x is equal to 8. Okay, so the function is equal to 8. Before you start doing this, just make sure your absolute value is by itself. So in this case, it is by itself. There's nothing outside of the brackets. So you can go ahead and solve for this. Okay? You're going to have two scenarios. First scenario is going to have, at this point, you can let go of your brackets and solve for your first scenario. Okay? Your other scenario is going to have 3x minus 2 is equal to -8. Solve for both scenarios, and that would be your solution for this, for your values of x. So in this case, I got x is equal to 10 over 3, and x is equal to -2 by simply solving for both of my scenarios. Okay, so let's, I'll give you a moment to try out C, so we can go ahead and pause the video and try out C by implementing the same concept we implemented for B. Okay, so you should have two answers. All right, so for C, so value of x for which f of x is equal to x. I've set it up equal to x. Again, you're going to have, this happens to be, the absolute value happens to be by itself. So I go ahead and split it up into positive x and or a negative x, and go ahead and solve for both those values. You end up getting x is equal to 1 and x is equal to 1/2. All right, for example 2, we're going to go ahead and practice graphing. So the first two examples we have is the absolute value of x plus 1, and for b, we have the absolute value of x minus 1 plus 2. Okay, so one thing you should know about absolute value is that it has the classic V shape as its graph, and you'll notice that when we actually go ahead and graph these. Okay, again, with this V shape, you're going to have a vertex. That is the first thing that you want to find out when you're given one of these functions. Okay, so let's actually start with B. Now with B, how do you find this vertex? Again, you need to find your x and y coordinate. How you find your x is you set whatever's in the absolute value equal to 0. So in this case, we have x minus 1 equal to 0, x is 1, that is part of my vertex, at least one half of my vertex. I need to go ahead and find my y value of my vertex, and here is where you can get your y value per vertex, okay? On the outside of your absolute value. So in this case, it's 2. Our vertex ends up being 1 and 2. Okay, well now, I need to find, let's say, a point on my right side and a point on my left side. So let's go ahead and let's say when I plug in 2 into this graph, or into this function, what do I end up getting? So 2 minus 1 is just 1. Absolute value of 1 is just 1. 1 plus 2 ends up being 3. So 2, 3. And let's go with something on the left. Let's say 0. Okay, what if I plug in 0? 0 minus 1 is minus 1, but the absolute value of minus 1 is 1, and 1 plus 2 is 3. So when I plug in 0, I end up getting 3. And as you can see, when you're sketching this, again, you need at least 3 points. It makes your V shape. Okay? Let's go to this one. Set this equal to 0. So x plus 1 equal to 0. You get x is equal to negative 1. Okay? To find your y portion of your vertex, well, there's nothing here. When there's nothing there, it's a 0. Y is 0. So I have negative 1, 0 as my vertex. Okay? Let's go with something on the right side. So let's plug in 0. 0 plus 1 is just 1. So when I plug in 0, I end up just getting 1. So 0, 1. Let's go ahead with negative 2, something on the left side. So when I plug in negative 2 plus 1 is negative 1. The absolute value of negative 1 is just 1. So when I graph negative 2, I end up getting 1. And again, you can see that graph forming. So here's how you graph A and B. All right, example 3. Example 3 has 3 parts. We'll do one after the other. It says function f is defined by x being mapped to the absolute value of 2x minus 1 for the domain, which is between negative 1 and 3 included. Okay. First part states to sketch the graph. We got to practice on the last example, and then state the range of your function. One thing you do have to remember that's it's restricted by this domain. Okay. So let's go ahead and find the vertex first. Okay. Set 2x minus 1 equal to 0. So once we do that, we should end up getting 1/2 for our x value. Okay, so 1/2 is our x value. There is nothing here, which means it's 0. 1/2, 0 would be your vertex, right? We need to go ahead, and again, we want to find those 1 point to the right, 1 point to the left, except we should remember that we're restricted by the domain, okay? I would use these values in your table. Okay, so let's go ahead and put negative 1 in. When we input negative 1 into this function, 2 times negative 1 is negative 2, minus 1 is negative 3. The absolute value of negative 3 is 3. So when I input negative 1, I get 3 back. Alright, let's go ahead and plug in 3 and let's see what our y value is. Plug in 3, I get 6. 6 minus 1 is 5. The absolute value of 5 is 5. Okay. Alright, let's connect these points. And let's see what our range is. Okay, it's going to start off. It's going to start off at 0. Minimum is 0. Okay, and it goes all the way up to 5. Okay, so this is our range. It's between 0 and 5. And again, we do have to consider what our domain is. So letter B. Letter B states, find the range of values of x for which f of x is less than 3. This can be a bit of a confusing question because range is affiliated with domain, or your x values. Okay, so what this is saying is, what is your domain, or what are your x values when your range is basically between 0 and 3? Okay, so you're telling me domain when range is between 0 and 3. So, in order to do that, we have to set our function, or set our absolute value, and set it equal to 3. So we have 2x minus 1 equal to 3. And again, we're going to have to separate this into two different scenarios, where we have 2x minus 1 is equal to 3, or we have 2x minus 1 equal to negative 3. Okay, we solve for them individually. Okay, so in this case, our values are 2 and 1. So, and you can see that from the graph as well. So let's look at 2. When 2, and again, this graph is not perfect, but it's just good enough where we can kind of tell if it's at 2, it is less than or equal to 3. If we manage to go to 3, for example, well, that range is going to be definitely a bit higher. Let's look at negative 1. So if you look at negative 1, our range is right at 3. But if I happen to state, well, if I happen to question you on negative 2, that range is obviously going to be a bit higher. So remember the question. What is the range? What is the domain when the range is less than 3? Okay, so in this case, our domain, considering our range is less than 3, is going to be between negative 1 and 2. Okay, for 3c, it states, sketch the graph y is equal to x plus 1. Let's go ahead and do that real quick.
Okay, and again, this is a quick sketch.
Alright, and hence obtain the values of x for which the absolute value of 2x minus 1 is equal to x plus 1. Okay, so essentially it's just asking you where they intersect. And again, we can get that according to the graph, but again, since this is a sketch, you should set this equal, or set both of these functions equal to each other, like it mentioned here. Okay, so you should have 2x minus 1 equal to x plus 1. And again, your other situation is, since this is absolute value, it's going to be 2x minus 1. And you're going to make this negative, in parentheses, x plus 1. So essentially, what you have here is negative x minus 1. So you should solve for both. Okay, so this is your first scenario. I basically simplified, and I end up getting, again, what is the x value? So your x value ends up being 2. Okay, so when we go ahead and solve for the other scenario, we end up getting x is equal to 0. So your answers are, again, your x values are x is equal to 2 and x is equal to 0. Okay, so I do want to mention my graph is not perfect here. So these two lines will intersect at 2, 0 and 0, 1. So 0, 1 you can see 2, 0 is not quite sketched very well. So that's why you cannot see it on your graph. But if you have a better graph, you will be able to see that where these two lines intersect, your x values are 2 and 0. Alright, so here's your practice problem for tonight. Sketch the graph and state the range. of the following function where the domain is between 0 and 3, including 3. Okay? So look back on, if you're a bit confused, look back on the example that I did earlier to kind of follow what you need to do here.